Been requested to answer some of the questions from the specimen paper from 2020. I was asked to do question 10 and 11. Question 11 is actually something that's outside of your syllabus. It's something that's going to be introduced for the first teaching from this September for those who are going to be examined in 2020. And it involves some sort of calculus and differentiation, which is at the moment AS level stuff. So it's going to come down into IG level. So you guys who are doing the exam in 2018 and 2019 don't have to worry about that at all. Okay, it's for the first examination in 2020 in the June, the first June 2020. That's when it's first going to be examined. So I won't answer that question now. I might answer it some other time when the new syllabus starts. Now, the question before that, question number 10, as you will notice, the specimen paper actually, a lot of, especially the paper 4, is made up of questions that came up in early years anyway. So I can't remember which year this came up in, but I remember this question. In fact, I think I gave it in my mock exam for my students. So this was a question that came up in an earlier year as well. They just put it in the mock exam, in the specimen paper. But they add some new style questions, which are from the new syllabus, of which the last question is of one of those. Anyway, 10a, show that the volume of a metal sphere of radius 15 centimeters is 14,140 centimeters cubed, correct to 4 significant figures. Okay, so here they've told us the volume of a sphere is given by this formula, V equals 4 over 3 pi r cubed. So it's a simple case of just putting the value of the radius into this formula and then getting your answer out. Okay, but you also have to show that it rounds to this value. Okay, so the units is no problem. This radius is in centimeters. The answer they want in centimeters cubed. You have to do any conversions or anything like that. So just do V equals 4 over 3 pi. So the volume is equal to 4 over 3 times pi times the radius, which is 15, cubed. And then all you need to do is go to the calculator. Okay. There's my calculator. I still have some days left, 87 days left on this one. Okay, and then I'll subscribe to it. So you have 4 over 3 times pi times 15 cubes times 15 cubed. Shift. Okay, 4 over 3 times pi times 15 cubed equals. Now, I advise you all to write this in the form that it comes out within the calculator first, 4,500 pi, because you might need this value in another part of the question. So leave that as it is, and then press this S to D button that changes it from, this is called surd form when it's in its exact form, to decimal form. So you have 14137. I'll write down a few of these. So 14137 point, and what was it? 0.16694, 166, Okay, you don't have to worry about writing all of them down. Just write some of them down. But you must show that it rounds to this in 4 significant figures. So this is the 4th significant figure. 1, 2, 3, 4. The number after it is greater than 5 or greater than 4. So you've got 1, 4, 1. So this 3 has to increase 1, becomes 4. And then any number before the decimal point, any space before the decimal point must be filled with a 0. So you can show that that's equal to 14,140 centimeters cubed. Okay, so that's part A. Now part B. It says a sphere is placed inside an empty cylindrical tank of radius 25 centimeters and height 60 centimeters. The tank is filled with water. Calculate the volume of water needed to fill the tank. Well, the volume of water needed to fill the tank is going to be the volume of the cylinder minus the volume of the sphere. Okay, because the sphere is taking the place of the water that would have filled the tank. All right. Okay, so that's the volume of water needed to fill the tank with the sphere in it. Obviously, that's what they mean. Okay, because the sphere is already placed inside there. So the volume of the water needed is equal to the volume of the tank minus the volume of the sphere. Now the volume of the tank, now for a cylinder, okay, they don't give you the formula. And notice for a sphere, they gave you the formula. A cylinder is a type of prism. It's a circular prism, okay, and they don't tell you the volume formula for prisms, nor do they tell you the surface area, okay, but they do for pyramids, okay, and for spheres. So here we have a prism. Okay, a prism, the volume of a prism is the cross-sectional area, which is a circle, okay, it's a circular, area here, times the height, how deep it goes. That's the cross-section, that's the part that doesn't change all the way through the shape. It's always a circle all the way through from top to bottom. So the area of a circle is pi times r squared, and you've got to multiply that by the height of the cylinder. So the volume of the tank itself is going to be the volume of that cylinder, which is pi times 25 squared times 60 the height. And from that, you've got to take away the volume of the sphere, which we already know in its exact form, which is 4,500 pi. So I'll write it in that form just to give ourselves more accuracy. So 4,500 pi, and that will give us our answer, okay? So what I'm going to do is, I'm going to do pi. See, this answer is already in the calculator, okay? This answer is already in the calculator. 4,500 pi. What I'm going to do is I'm going to do pi times 25 squared, so pi times 25 squared times 60 minus my answer. The answer is the last answer that appeared the last time I pressed the equal sign, which was that 4,500 pi. So you get 33,000 pi. So that's 33,000 pi, which you then press the SD button to give your answer. We want to give it to 3SF because it doesn't say anything else. All right, it doesn't tell us 4SF this time. It says 3SF. It doesn't say 3SF, but the general rule is if the accuracy is not mentioned, you do 3SF. That's going to be 104,000. I'll write it down as it says 103,672 point something, 0.55, 0.55 dot dot dot. So it's 104, and then you got 3 zeros. 104,000 centimeters cubed, and that is the answer to part B part 1, and then I'll do B part 2. It says the sphere is removed from the tank. Calculate the depth of water in the tank. So now, if the sphere is removed from the tank, okay, then we can see that the volume of water in the tank is 33,000. Okay, 33,000 pi. That's the volume of water in the tank. Okay, 33,000 pi is the volume of water in the tank. We just worked that out before. Now, if that's the volume of water in the tank, okay, and the sphere is removed, now the water is taking the shape exactly of just the cylinder without the sphere being in there. So if you want to work out now the depth of the water in the tank, we just take the volume of water divided by the cross-sectional area, okay? Because we know that the volume is equal to the cross-sectional area times the depth. Now the cross-sectional area, okay, which is the area of the circle, is pi times 15 squared, because the radius of the tank was 15, because we know from above. Okay, sorry, not 15, 25. See, that's the problem when you can't see the questions on top. It's 25. You've got to be careful about making silly mistakes, especially when you're in a bit of a rush like I am today, because I have so many questions to answer. So pi times 25 squared. Okay, it's 25. The radius is 25. Be careful. Did I use 25 here? Yes, I did. Okay, so and then you multiply that by the depth, which you don't know. So what do we know from this? We know the volume. So we know 33,000 pi equals 25 squared times pi times the depth of the water. So we can see here that the pi's will cancel out. Okay, that's one good thing about leaving things in terms of pi. So you're going to have 33,000 divided by 25 squared, and that will be the depth. Everything's in centimeters here, so there's no worries about the units. So basically you're going to have 33,000 divided by 25 squared. So 33,000, 1, 2, 3, divided by 25 squared. I think that's 625. Anyway, that gives you 264 over 5, which is 52.8 52.8 centimeters. So that's 52.8 centimeters. Okay, 52.8, and that's our answer. And I'm going to go on to the next part in the next video. Thank you very much for watching.